So for problem number 5, we're asked to use algebraic manipulation to show that these two rational functions are indeed equivalent. So looking at g of x, I see that this is one big fraction, but h of x actually is a non-fraction minus a fraction. So this is actually going to be my starting point. Well, I'm going to immediately turn that 3 into a fraction just by writing it over 1 and leaving the other fraction the same. Taking a look at this, I know that the only way I'm allowed to subtract two fractions is if they have the same denominator. Because this denominator is not x plus 2, I'm going to take that 3 over 1 and I'm going to multiply it by x plus 2 over x plus 2. What that's going to do is it's going to get my x plus 2 that I need on the bottom of that first fraction. And then we're just going to bring the x over x plus 2 straight down. Now taking a look at what happens here, I can see that it's going to be 3 times x plus 2. So if I rewrite this next step, it's going to look like 3 times x plus 2 all over 1 times x plus 2, which is just going to be x plus 2, minus 6 over x plus 2. Now that these pink fractions have the same denominators, I can actually just push everything together and rewrite it as 3 over x plus 2 minus 6 all over x plus 2. If I then distribute this 3 inside of the parentheses, what I'm going to get is that I'll have a 3x plus 6 minus 6 in the top, and I can see that the 6's would cancel out, and then it would still be over x plus 2. When I look up here, I see that 3x over x plus 2 is exactly what g of x is. So I can say that 3x over x plus 2 is really the exact same thing as g of x.